Hello world! Welcome back to another CTFlearn challenge video. In this video, we'll be walking through the binary challenge, RIP my BOF. Let's get into it. Okay, so we have a BOF. Can we get it to redirect IP instruction pointer to something else? If you get stuck, Live Overflow covers you again. Alright, so for this one, they give you a netcat portal to connect to and some files to download. We'll definitely be using all of that. A BOF is just a buffer overflow, so we know what we're looking for. If you download the tar.gz file, you'll get these two files right here, a bof2.c file and a server file. The server file is the ELF file running on the back end, and the bof2.c is the source code that was compiled into that server executable. That being the case, let's go ahead and connect to the netcat portal they give us just to see what we're dealing with. And they give us a nice stack visual here with everything kind of labeled. We're going to want to try to overwrite the return address here with something else, which we'll be able to see what that is in the source code in a second here. But let's go ahead and just test to see if the buffer overflow is working as the challenge suggests. We'll just put in a bunch of A's. And indeed, we see we have some sort of vulnerability happening here because we are able to overwrite the return address down here. All right, let's take a look at our bof2.c file. We can see that the main function is called down here. A vuln function is called here. If we look at the vuln function, we can see our exploitable statement right here. Gets is vulnerable to buffer overflows, and we probably want to overflow it with the win address because that will give us our flag. So how do we go about doing that? Well, we need to figure out what the overflow offset is, and that's going to be however many characters it takes us to get to the return address. Now, we can easily just count up how many of these characters there are in this stack until we get to the return address. Each line has 8. There are 1, 2, 3, 4, 5, 6, 7 full lines. That's 56, 57, 58, 59, 60. So our offset should be 60. And we can easily test that by running a Python tech-c, and we'll do a print a times 60 plus, and we'll do a b times 4. That way we can actually see the differences in our stack there. And we'll pipe that into our netcat portal here as input. And we can see we've successfully overflowed the return address with our 4 B's because 42 is capital B, 41 is capital A. Okay, now that we know that works, we can simply replace those B's with the address for the win function. And we can easily figure out what that is by running obj dump tacd server grep win. You can also do read elf tacS server grep win, and you want to run this on the binary because that's the compiled executable. And we can see our address right here and right here. Now you're going to want to do this in Little Endian, which means we're reading the bytes in backwards. So our full exploit will look something like echo tac-e, and tac-e allows the echo statement to recognize escape characters. We'll do an interpolated Python command here to get our A's. And then we're going to type in our win address in Little Endian. So we want to do \x86, \x85, \x04, \x08. And \x is used to represent a hex value. And then we'll pipe that into the netcat portal. Press enter. You can see in our stack here that we've successfully overwritten the return function that they had there originally with the address to our win function. And we get our flag. Controlling RIP is not too hard. So we'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.